In college algebra, we practice simplifying radicals and factoring polynomials. So maybe hit pause and try and simplify these without help. Remember, no decimals. All right, I'm going to go ahead. We need to break 40 down, and a nice way is to go 40 and 10. Really, at that point, you can stop. But if you want, you can continue on and break that 10 down to 5 and 2. But 5 and 2 are not perfect squares, and 4 is. So it comes out, becomes a 2, and the 5 and 2 are left inside. But instead of 5 and 2, let's remultiply them, and we have 10. On number 2, I would reduce that fraction first. So I'd reduce it down to 2/5 y squared. And then I would break it into two radicals. So we have square root of 2 over square root of 5y squared. Now the y squared is a little distracting, so if you want to hold off on y squared until the very last step, that's fine. But hopefully you realize y squared comes out of the radical as y. But the problem is we have a 5 in there, and I need to get rid of it. So if I multiply by square root of 5 over square root of 5, that's going to get rid of 5 in the denominator. So that ends up being square root of 10 over 5y. Because square root of 5 times square root of 5 is square root of 25, which is 5, and square root of y squared is just y. That one's a mess. That one's the hardest one of the 6. All right, this problem, hopefully everyone knows square root of 49 is 7. And if you need to, break that x into 3 x's. So square root of 49 is 7. I see a pair of x's, so that can come out as just an x. But that other x is all by itself. Oh, let me get rid of that red x. That looks weird. So that other x is left inside. Looks a little confusing with number 2 invading on that space. All right, on number 4, that one should be easy. Square root of 400, if you need to type it in, that one is just 20, right? And if you need to, write that x 6 times, and you'll see you have 3 pairs of x's. Or you could write it x to the 3rd times x to the 3rd. So that pair of 20s comes out as a 20, and that pair of x cubed comes out as x cubed. On number 5, you want to reduce that fraction first. So that goes down to 5/3. And then I would break it into 2 radicals, and then I would multiply by square root of 3. And you want to multiply by square root of 3 because you need that radical to disappear from the denominator. So that ends up being square root of 15 over 3. You cannot divide those because one is in a radical and one is outside the radical. 15, it does break down to 5 and 3, but neither of those are perfect squares, so it's just stuck. All right, I think number 6 should be the easiest, right? Square root of 400 over square root of 36. That ends up being 20 over 6, which reduces to 10/3. Right? Hope everyone's good with that. Or actually, I'm going to show you a little factoring before I end the video. Whoops. So yesterday we started this handout. We did numbers 1 and 2. We're going to do numbers 3 and 4 today. And we're going to start out with factoring by grouping. And it's a little tricky, so I'm going to write down some steps. If you have 4 terms, try factoring by grouping. And I'm being very blunt and saying try. It may not work. So it is truly just an attempt, and this may not be factorable. Step number 1, group first 2 terms with parentheses. Group last 2 terms with parentheses. So let's do that. I group the first 2, x cubed plus 4x squared. Notice there's a plus sign right here, so that plus sign has to stay there. So I write plus. And then I group the last 2. 3x plus 12. All right, step number 2. Take out a GCF from each group. So GCF in the first group, they both have an x. Go to your smallest exponent, and I can take out x squared. Then write the leftover. We still have 1x in that first term, and I still have a 4 in that second term. If you struggle with that, distribute the x squared, and you should end up with what you started with. That's a way to check your work. For the next one, they both don't have an x, but they do both have a factor of 3. So I can take a 3 out, and I just have an x left on the first term, and 12 divided by 3 is 4. And that's step 2. All right, this is a sign that it worked. If the leftover portions of, that should be plural, of each group are the same, then that is the GCF. Factor it out. And look, the leftover portions are the same. If you look back at number 2, this looks very similar. Both of these have an x plus 4, so according to step 3, x plus 4 becomes our new GCF. You factor that out and write the leftover. So I write x plus 4, that's the GCF, and then the leftover is the old GCFs. It's very weird. So I have leftover x squared plus 3, and that's it. Number 4 is very simple. Number 4 is your traditional factoring problem. It's if you have a 1 as the front number. If the front number is a 1, then find two numbers that multiply to the last and add to the middle. If you need to, sometimes, what is that? So if you need to make a T-chart, sometimes you get some large numbers and it's hard to do in your head. This one's pretty simple though. But I want two numbers that multiply to 8, but add to 6. For example, 8 and 1 does not work. They don't add to 6. But 2 and 4, those add up to 6. And that's your answer, and you're done. The way you write it is, let's see, I have room over here to the right, x plus 2, x plus 4. And that is literally all you do. You can do all of that in your head if you want and just write the answer. Problems like number 5 are tricky. We'll do that tomorrow. See y'all later.